Alright folks, thanks for coming. Hey, today we're gonna continue where we stopped yesterday. We're gonna continue dealing with the real world applications of linear equations in one variable. And this is part 3. I still got a couple of stuff to cover in one variable. You're gonna see varieties, different flavors of problems. Like today, we're going to have a bunch of transportation problems, like a car travel from one distance to another car, travel the same distance, different speed, something like that, So, we've got a bunch of problems in this area, linear equations in one variable. Then after that, we get into 2 variables, okay? So, bear with me as I cover a bunch of this, because I'm doing this on purpose. Like I said, we're gonna help people in that want to take GED exams. Possibly, eventually, I'm gonna get into GRE and GMAT. Okay. So, but let's continue. I don't care what exam you take, GRE, GED, GMAT. They give you the same problems, man. The same application problems. Using linear equations or the other things we'll cover, like rational functions, polynomial functions, So keep in mind, this is still part of the algebra we've been doing, algebra 1. So we're gonna, after this linear equation, we'll go into other stuff. And then from there, we'll go into algebra 2. From there, we'll go into pre-calculus. So there are different things we'll cover. Sometimes things are repeated, but it's okay. If it's repeated, it gives you opportunity to learn it better. See, so but anyway, so we're gonna kick off today. We're gonna solve a bunch of problems. So stay with me. It's another marathon today. Before we start, please subscribe to my channel, like and share this video. Leave comments or questions under the video, then I will get to them as soon as I can. Alright, thanks. Let's go. Here's example number 1. Let's read it carefully. It says lot A in the survey plot, okay, is in the shape of a trapezoid. The parallel sides measure 26.84 feet and 82.05 feet. The height of the trapezoid is 165.97 feet. Find the area of lot A. Round the answer to the nearest hundredth of a square foot. Yeah, there's another problem. I tried to understand it. I couldn't understand, but this one is clearer, because you see, if you look at the 2, this is lot A. You see lot A here? It says lot A here. This is a different lot. So the other problem didn't make it clear. This one made it a little clear. Because if we see, remember yesterday we dealt with triangle. This is a triangle, okay? Not a triangle, sorry. Yesterday we dealt with a rectangle. We also dealt with triangle, okay? This is a rectangle. See, that part there is a rectangle. This is a rectangle, okay? Not a triangle, rectangle. But you see, this part here looks like a triangle, but it's not quite a triangle because of this part here. Alright. So that's why they call that trapezoid. It has quite different parts. Look at that there, look at that there, look at that there, look at that there, and look at this here. It's quite confusing. And then this here. Okay, so but they gave you this, which is that. Let me see, 26. Yeah, they gave you that 26.84. Okay, it's all confusing, man. And they gave you that 82.5. Where is it? It's this part here, 82. I don't know why they wrote this one here. Anyway, and then they gave you the height of the trapezoid. That's the height. The height is 165.7. So basically, This is the height right here. Okay, so the thing is, we're not dealing with the rectangle. Okay, just keep that in mind. So like I said, the whatever exam you're doing, they're gonna give you certain areas, and the formula for area or different geometric shapes. So area, the area of the area of a trapezoid. Okay, a trapezoid. The area is given as 1/2 of the height, all right, times b plus big B. See, big B is this one, see, because it's a higher. Then small b is this one. See, so the small b is 26.84, which is that. The big B is 82.05, which is that, right? And then the height is that. You see that, right? So we got forget about this thing. This thing plays no part in solving the problem. Okay, you just have to use what you require to use to solve the problem. So here's what we'll have from the problem. We'll have h is equals to, what is that thing? If you look at the problem right here, 165.97 feet. Okay, don't worry about the units. And then a small b is that one is given. They say the parallel size. The small one is equals to 26.84, and the longer one is big B is equals to 82.05 feet. You can see, compare them. You see, so this one is here small, and this one is here bigger. Okay, so that's all you're given, and then you put all that information in the formula. You should be able to solve it. Okay, that's all they want, man. All right, so you say area is equals to half, and then height, put the height 165.97. Okay, and then put the small feet, the small parallel side is 26.84 plus the longer side, which is B right here, 82.05. That's all. Okay, everything is in feet, so you solve that. That's all you gotta do, man. Don't they give you a strenuous unnecessary information you don't need. Don't worry about it. Just use what you have to solve the problem. They say round the answer to the nearest 100. Okay, fine. Now let's pull out our stuff and solve this problem. Okay. All right. So what you do, you start from the bracket to start simplifying. You see, inside the bracket, you solve that first. You say half 165.97. I'm talking about this bracket here, this one here. You add that together, you get 108.89. Okay, that's what you get. So, and you multiply this and that. You could divide, but let's multiply first. If you multiply those, you get 1/2. Let me see, 1/8. Hang on a minute. Yeah, 18072.47. Okay. Okay, so you get that. Then you divide by 2. You divide by 2, you get 9,036.24. I rounded it up to 2 decimal places. That's what you get. And this is that thing is in feet, right? Yeah, it's in feet. It's in feet right there. Okay, so 9,036.24, actually square foot. Okay, that's square foot. So we're done with that problem. That problem is a little confusing, but all right. Here is example number 2. You gotta be careful. Look, you read this thing very carefully. Say the U.S. Postal Service requires that any box sent by priority mail have length plus girth. That's distance around, right? Totally no more than 108 inches, right? The maximum volume that meets these conditions contained by a box with a square end 18-inch on each side. 18-inch on each side. A square box. A box with a square end. So this is square. Inside. So they're saying this is square. See right here, this is good. This is square. Right here, they're saying right here is 18-inch. I'm sorry. The way they state the stuff is confusing. That's why I told you gotta pay attention. See, wars will kill somebody. Wars are not good. This 18-inch, this 18-inch, this 18-inch, and this is 18-inch. Okay, that's all they're saying there. If you understand that, then the rest of the stuff are easy. So the girth is 18-inch. So basically, what they want, what is the length of the box? What is the maximum volume? So they want volume, all right? They want volume and they want length and the volume. Okay. What is again? The maximum volume that means this condition containing okay. The length plus girth. All right. Oh man. The length plus girth is has distance around. It's totally normal. The length. Okay. All right. Your stuff is confusing, man. So the girth. Let's start with what we know. The girth has. There are four of them. Four of those. It's a square end. So if you multiply 4 times 18, you get 72 inch. Okay, that's what you get there. Okay, I don't know what we're gonna do with this. Let's keep going. And then it says length plus girth, right? Length plus girth is what? Maximum 108 inch. Okay. Okay. I see what they're doing. Here's the thing, length plus girth. You remember we calculated girth here is 72. Is equals to 108. This is a linear equation in one variable, okay? So L is equals to 108 minus 72. It's kind of confusing. If you do that, you get L is equals to 36, okay? These are, everything is in inches, okay? And then the volume. Let me see, the volume of a box. They're supposed to give you this formula like I've been telling you. The volume of a box, let me see if I can find it. They're supposed to give it to you. So you don't have to worry about it. That's a rectangular box. It's not a square box. The volume, right? The volume of a rectangular box. The volume of a rectangular box. How do you get that? Hang on a minute. Let me see. Oh, okay. The volume. Actually, you know what? That's why they label. See, they label that. So the volume should be that. The volume should be length times width times height. That's the volume right there. Let me just give me a minute. Yeah. Rectangular solid, yes. The volume of a rectangular solid is length times width times height. They will give you that. So don't worry about that. A rectangular solid has that volume right there, the formula. So you put the stuff, you calculated this. So if you did that wrong, then the volume will be wrong. It's 36. What is the width? Let me see. We got the width, right? Where is the width? What is the width? The width is 18, sorry. Yeah, it's 18, you see? 18 inch, right? The width is 18. And the height is also 18, yes. I hope you see that, man. See, they put the width here. Let me clear that. This is the width. The width is here. Okay. We calculated the length. Then let me see, the height. The height is here. This is the height here. The height is still 18. You see that, right? So you multiply that out, you get a 1664 inch. Okay, 11,064 is cubic, because the volume is in cubic. You multiply three things together. Okay, and then we're done with this problem. Okay, all right. Here is the next problem. You see right there is sandwich, man. But you gotta sometimes the diagram will help you, because I've been looking at it. It says, I read it, one of the world's largest sandwiches made by Wild Woody's Chill and Grill in Roseville, Michigan was 12 foot long, 12 feet wide, and 17.5 inch thick. That's 1/1124. That's then 11/24 feet thick, right? What was the volume of the sandwich? So you always gotta pay, even if you don't see the picture, but look at what they say. This is the length, this is the width, right? The length and the width. This is the, let me see. Yeah, this is the length and the width, okay? But it's kind of confusing though. And then the thickness. The thickness is there, the express in feet right there. It looks like it's a square, but it's not quite a square. Well, the length of such the volume of such an object, right? The volume, even if it says it's not a square, it looks like a square box or something. It's not a square box though. Why do I say that? It's kind of confusing. 12 feet by 12 feet. Then, yeah, I don't know, man. We'll take that as rectangular, man. The volume is it's a little bit. It's not drawn to scale. It's length times width times height, and this is the height here. So that's the volume there. We'll have to use that. It's not even a cube. It's not a cube. A cube, everything is the same. You see, for a cube, the volume is like a three sides like that, because the three sides a cube, the three sides are the same. So this is not a cube because the three sides are not the same. You see that, right? So this has to be the volume there. So we substitute what is given to us. That's all we gotta do, man. You substitute what is given to you. So see, another thing you learn from there, from here is you gotta use when you're doing a problem like this, you can't use this. You can't multiply this with that. You can either express feet, change feet to inches, or you can use those 2 feet plus this feet here. So you have to use one unit. That's all I'm saying. So we'll do it this way: 12 feet times 12 feet times 1/11/24 feet. That's the way these are all in feet. So you can multiply with 17/1/2. To multiply with that, then you have to change 12 feet to inches, and then 12 feet to inches. So this is the best thing. We can work with that. I hope you see. Well, you don't want to mix units. If you mix unit, then you come up with the wrong answer. That's all. So you gotta always try to use the same unit. You see. That's all I'm saying there. So 12 times 12 is 144. Okay, and then we'll multiply that with 1/11/24. Now, how do you approach this thing, man? Yeah. So what we can do is we can use calculator, but we don't have to. Okay, notice something. 1/11/24 is the same thing as, because what happened? Something got divided by 24, and then they got 1, and then 11 is left. So basically what is up there is 24 plus 11/24, okay? Make sure you understand that. We did that when we did arithmetic. So that's 35 over 24, okay? Alright. So basically what we're multiplying is 144. We should have left that. 144, 35 over 24. Okay, so 12 can go, let me see, 24 can 24 divide 144? That's the question. Yes, it can. 24 divide 144, you get 6. So this divide that, you get 6. Okay, so this is 6 times 35. So what is that? 6 times 35 is 210. Right? Yes, that's 210. 210. And since we're looking for volume, it will be feet cubed, like that. It's cubic feet. So that's the solution there. And then we are done with this one, okay? Alright, here is the next example. It says, this is example 4. I'm going to try to go a little bit faster, okay? It says that a driver averaged 53 miles per hour and took 10 hours to travel from Memphis to Chicago. What is the distance between Memphis and Chicago? Now, of course, if you drive, you should know this. Even if you don't drive, you should know this. When it comes to distance between two places, right? And if you're driving either a bike or a car or a motorcycle, usually what they say is distance is equals to rate at which you are traveling, right? Let me see, rate at which you were traveling, alright, times time, okay? Okay, sometimes you see these, you see the same thing. You see rate equals to distance travel over time, okay? Alright, but it's the same thing. They just switch things around, okay? So here we are given everything. Well, the rate is in mile per hour, and the distance, no, the time is in hours. So we'll leave it like that. We'll leave the unit like that. So we'll substitute the rate is equals to 53, and the time is equals to 10, okay? You just put it in this equation. You have the equals to 53 times 10, okay? And that would be 530. That's mile. This will be miles, okay? You know, because everything is in mile per hour, okay? And then the hour is in hour. So the distance, then what that means, the distance between Memphis, okay? Memphis and Chicago is 530 miles, okay? That's all that is saying. So we'll find the distance and we'll move on. We're done with that one, okay? We'll move on. The next one says, let me make sure you can see that, okay? It says that a small plane traveled from Warsaw to Rome, averaging 164 miles per hour. The trip took 2 hours. What is this? Again, it's the same thing. What is this from Warsaw to Rome? They changed the word. You know, you could say the plane traveled from Houston to Dallas, averaging 64 miles per hour. The trip took 2 hours. What is the distance from Houston to Dallas? Basically, it's the same thing. So distance is equals to rate times time, and we're given the rate Rate is 164. Time is 2. Okay, so we get distance equals to 164 times 2. That's all. You multiply that by 2. That's 8. That's 12. That's 2, 3. So this is what you get. Okay. 328 miles. Okay, we'll move on to the next one. We'll try to knock as many of them as possible. So you can see this. You see what it says there? It says that the winner of the 2016 Indianapolis 500 mile race was Alexander Rossi, who drove his Dallara Honda at a rate of 166.634 miles per hour. What was his time to the nearest 1,000 per hour? Okay, again, you see what they're doing? Now they're looking for time. So you just use that equation, substitute what is given, and you solve it. That's all. So we'll have rate. That's the same thing we'll be using. Rate is equals to distance over time. Okay, I just switched it around. I hope you see that, because the rate times time is distance. Okay, I'm sorry, we're looking for time. So what we're gonna do, we'll write it the way you see it. It's time. It's time. T is equals to distance divided by rate. You see it, right? Because what we did before, we did distance equals to rate times time. Okay, you divide both sides by with distance. I'm sorry, you divide both sides with r. Okay, if it helps you to see it, that's what we just did. So you get distance divided by r, and then the other side divided by r. Okay, then t is left standing by itself. We are given r equals to 166.634, and we are given, what is that in there? We are given distance. They say distance is 500. I hope you see it right there. So you gotta get through the words. Don't let the words, don't hang on the words, man. So what we're looking for is time. So then we'll get 500 over 166.634. So don't hang on words, man. Just look for the constants you need to solve the problem. Once you find them, then solve the problem. Don't worry about the words. Sometimes they use the words to try to confuse you. Okay. So the time he used is 3 point. The time he uses 3 point. I think it's 3 hours, man. What is that? Is it? Yeah, the time is he uses 3 hours and 3.0. What is that? 3.001. Because you want to do it to the whole. What do you say? 1,000. So that's to the 1,000, and that is seconds. No, that's hours. That's hours, because everything is in mile per hour. Okay, so we're done with that one. I hope you understand what I just did there. Let's move on, man. I want to knock out as many of them as possible. That way you can see that we're still in linear equation in one variable. Okay, we're gonna get to 2 variables. We'll try to get there today. Okay, it says in 2016, Carl Bush drove his Toyota to victory in the Brickyard 400-mile race at a rate of 128.940 miles per hour. What was his time? Again, we need time. Time is, what is that? Time is distance over rate. Okay, time is distance over rate. So here we're given that the distance, we're given rate here. So we'll substitute, we'll get 400 over 128.940. So if you see this problem anywhere in the exam, this is how you solve it. You see, this is mile per hour, this is mile, so you don't need to change the unit. You just put that stuff in there and knock it out and go, okay? Don't worry about the words. Don't let the words get in your way. Too many words sometimes, you see. So, but you gotta learn how to avoid unnecessary words you don't need. So this is equals to 3.1. What is that? 3.1. This is time, hour. Okay, it's hours. Okay, this is 3.1. Well, they said to the near. What is this? Did they say to the nearest 1,000? So it will be. Let me see. 102.102. Okay, because I tried to cut it off, but since they say nearest 1,000, you need them. You need it like that. So we'll move on to the next one. We'll knock out as many of them as possible, man. So the next one is from a point on a straight road, Marco and Celeste ride bicycles in the same direction. Marco rides at 10 miles per hour. Celeste rides at 12 miles per hour. In how many hours would they be 15 miles apart? Do you understand that problem, right? So you're given two rates, right? You're given two rates, and they're heading the same direction. That's important. They're not heading in opposite. You will see problem later that heads in opposite direction. Here are the two rates. They're heading in the same direction, right? And they want you to find in how many hours would they be 15 miles apart? Because you see, their rates are different. So of course, one is going faster than the other. So this is a kind of a little confusing problem. So you gotta try to solve that equation. Don't forget what we said. We said that let me see. Basically, in how many hours? It's about time, okay? It's about time, but so the best way to do this is to say, yeah, this is a little deeper. Let's say, remember I said that rate is equals to distance over time, right? So you got three things there. You got rate, you got time, you got distance, okay? So what you need to do in this case, okay, how many hours would there be? I think you gotta make a chart. You gotta make a chart, that's all. Oh man. Because listen, you gotta make a chart for both of them. For Marco, you gotta make a chart for Marco. You make a chart for, what is that guy, Celeste, okay? And then you say, let's list the stuff, okay? Let's list, you have rate, we are giving rate, there's time, there is distance, okay? Those are the three things: rate, time, distance. You just have to try to visualize the problem. For Marco, let me see, Marco has 10, rate 10. We're looking for the time, right? And then he has, let me see, we don't know, we're looking for the time. We're looking for, time is the one we're looking for. Okay, remember that, let me see, Remember that distance equals to what? Let me see. Let me go back. Distance is equals to rate times time. Okay. Yeah, I think that's what they want. Distance is equals to rate times time. Okay. Yeah. Yeah. Distance, rate over time. So, because we're looking for time. So, we're looking for time. We'll let t. Well, we already used t be time. Okay. And then we'll say, since we'll have the distance, right? Let me see. What do we have? No, I'm sorry. We'll have the. Okay. Right here, you're gonna say t. 10 times t is the. I think we'll have to form an equation. Is the distance. We don't know t. Okay, we don't know t. We do the same thing for Marco. Marco is going at. Celeste going at 12. We're looking for t. We'll say 12 times t. Okay, that's the distance. Okay, right there. This one we don't know. This is the variable we're looking for. We're looking for t. We'll call it t. Okay. So 12 times t. So basically what they're saying is the distance, because Marco is going faster, right? Marco is going slower, right? Marco is going slower. Marco is going at 10 miles per hour. Celeste is going 12 miles. So Celeste is going faster than. This is a little bit confusing, man. So somehow, well, I don't know, man. Just give me a minute. Let me think about this a little more. Okay, I think I got the point. I should have given him more time before I put it here. Listen, because you remember this guy is traveling faster than this guy. Celeste rise faster, way faster than Marco, 2 miles per hour faster, right? So what's gonna happen? And then they're gonna be. They said they're gonna be right there apart, right? So what you're looking for is it's gonna be like this 10, 12 t for Celeste minus 10t. This is don't forget now. This is the distance they travel, because Celeste will travel more distance than Marco, right? Distance they travel is there. He's gonna be traveling a little more. Cover more distance than this guy here. So you said that would be equals to 15. It's still not very clear. It will be equal to 15. This is an equation we need to solve, and then we'll get the time, because we're looking for the time. The time they will be 15 miles apart. Okay, so we'll solve that. So that's in 15 miles. They will be apart like that. You can visualize it like that, you see. But anyway, so you solve that, because this is, we're dealing with the equation, linear equation in one variable. So you do that to simplify the left side. What do you get? You get the, let me see, you get 2t, okay, it's equals to 15. And you get t equals to 15 over 2. And that is 7.5, right? 7.5 hours. That's when they will be within 15 miles, right? They will be within 15 miles. They will be when they are 15 miles apart, they will be. It would take 7 and 7.5 hours. That's all that is saying. Because you gotta understand, this guy going faster, and this guy is going. So this guy will get more miles, and this guy will get less. So you subtract them, you equate them to the, to the mile apart, okay, and you solve. You just have to try to remember this kind of problem. It's a little bit confusing, but it's okay. So we're done with it. We'll leave it alone. That one gave me a little bit problem, but you gotta think through it and try to understand it, okay? Okay, look at this. This is the same problem again. You see, the same problem. So you gotta try to understand how to solve it. They say these are at a given hour, two steamboats leave a city in the same direction. They're heading the same direction, the same problem, the same direction. One travels 18 miles per hour, the other travels 24 miles per hour. In how many hours would the boat be 5 miles apart? You see the same problem. So if we do the same thing we did, the first boat, two steamboats, the first boat, the first boat will have, what is that we did before? It would be RTD, based on how we solve the other one, I can write the equation and say RTD. The first boat, the rate is, let me see, 18, and we're looking for T, okay? And the distance is what, 18 T, okay? The second boat, that's boat 1, boat 2. The same thing, RTD. You have, what is that, 24 T, we're looking for T, 18, oh no, I'm sorry, that is not 18, that is 24, okay, I'm sorry, what the hell, that is 24 T, okay, alright, so basically what they're saying is, they're gonna be these apart. So that means from the way we solve the other one, this one is going faster and that one is going slower. So this guy will get more miles, this guy will get less miles. So you basically say 24T minus 18T will be equals to 9 miles. That's all. That's how you set up the equation, okay? So once you set it up like that and you solve it, some of these problems, something like this, you gotta try to remember, the way we set it up. That way, if you see it in the exam, you just set it up like that and solve it, okay? So this is a linear equation in one variable. You simplify the left side, you get, what is that? You get 6, that's 60, right? Hang on a minute, let me think. Yeah, that's 60 is equals to 9, yeah? And then divide by TT is equals to 9 over 6. That is, let me see, 3 over 2. Okay. Alright, 3 over 2, see, because we're dealing with hours, right? That's time hours. Everything is in mile per hour, okay? That will be 1.5. That's all that's saying, 1.5 hours, okay? And then we're done with that one. Basically, we're done. Alright, look at the next one. The next one is really, it's a little bit, it's like the other one, but a little bit of, see, really careful. Atlanta and Cincinnati are 100 miles apart. You see, they give you a picture. See, Cincinnati, Atlanta, they're, 440 miles apart, okay? And then he said John leaves Cincinnati, heading towards Atlanta, and Pat leaves Atlanta. See that picture? Heading towards Cincinnati, and John is going what? Let me see. John is going 60 miles per hour, okay? And Pat is going 28 miles per hour. Okay, so when are they gonna meet? They will meet somewhere. They will meet and cross each other, right? You see, look at that. They did that same thing we did before. For John, John is going 60 miles per hour, right? And then we're looking for T. Let's say we're looking for T. How long? And then you see the distance here. Distance is time times rate. They do the same thing for path, right? But now this is where they will meet. You just have to try to conceptualize the problem. They will meet somewhere going at different rate. So where the distance where they will meet. So you giving distance, you just have to work with what you're given. Try to understand the problem. So what happens is, see, we're gonna work with that 6t plus 28t is equals to, see, it's plus because that's where they will meet. You see, that's where they will meet. Distance traveled by John and distance traveled by Pat. If you add them together, it will give you the total distance there. The boat travel, which is 400 and 440. Okay, all right. If you go back over here, the one we just did, the earlier example 9, we're talking about here. The people are going in the same direction. One travel 18, one travel 24. And he said, how many hours would the boat be? 9 miles apart. Okay, so 9 miles apart means 24 minus 18t equals to 9. So remember that this time, this is where they will meet. So it must be, you add that, then find the distance, okay? So this is a simple linear equation in one variable. You add those, simplify the left side, you get, what is that? 88t is equals to 440, yeah? 88t is equals to 440. Then t, divide both sides by 88. You get t equals to 440 over 88. Okay? So if you do that, you get 5. Alright? If you divide, what are you doing? You're dividing 440 divided by 88. Okay, you get 5, okay? So once you do that, basically you're done. So this thing is saying, that 5 hours is saying that it will take 5 hours for the two guys, their cars to meet somewhere. It will take 5 hours, man. They will meet. It doesn't say where, but they will meet somewhere in 5 hours, okay? That's all that is saying. They will meet somewhere in 5 hours. So try to understand how, this problem, and then you think about it, then you move on. All right, look at the next one. It's similar to the one we just did. One plane leaves St. Louis going towards Portland. One plane leaves Portland going towards St. Louis. And they are this miles apart, right? You see the one going, that one going, where would they meet? You giving them, they already formed the stop for you. Okay, the plane leaving Portland. Now the plane leaving Portland, they going, let me see. Okay, let me read this. St. Louis and Portland are 2,060 miles apart. A small plane leaves Portland, traveling towards St. Louis. That one going 19 miles an hour, okay? Leaves Portland, 19 miles per hour, okay? And the one that leaves St. Louis, at the same time, traveling towards Portland, travels at 116 miles per hour, okay? So don't let the word get it. Just get the numbers and work with it. Forget about the words, man. You just need to understand. If you can draw a diagram, where are they gonna meet? That's all. That's the question. And you form this using that, right? And using the t as a variable. Okay. So distance here is 90 times t. Right here. Distance on the other plane is 116 times t. Where would they meet is, you add them together. Okay, so basically what that says 90t plus 1160 is equals to 2060. That's all. If you can be able to form that, you're done. Because all you gotta do the same thing we've been doing. Try to simplify it, simplify the left side, and then you're home free. Okay, so that's all that is called for. Don't overthink the problem. Don't you see this problem in physics? Well, if you do physics, you will still meet the same problem. You see, so but do not overthink it. You just add this stuff and move on. So this is, you add the left side. What do you get? Let me see. You get 2. Okay, so 6. You get 0. You get 206. Okay, 206t is equals to 2060. Okay, you divide both sides by 206. Then you say 2060 divided by 206. Okay, that's what is going on there. Once you do that, you notice what is going on. This is 206. It's like 206 times 10. So you cross this out, you're gonna be 10. So t will be 10. Okay, that's all that is saying. So it would take the two planes 10 hours to meet, because t is hours. That's all that is saying, man. You would take them 10 hours to meet, and we're done with this one here. We'll move on to example 12. Let's see what a train leaves Kansas City, Kansas, and travels north at 85 miles per hour. Another plane leaves the same time, travels south at 95 miles per hour. How long will it take take before the? Okay, see, it's like the first one we did. It's like this one. Now, how long will it take them to be apart? You gotta pick on it. How long will it take them to be apart? So remember what they did? We subtracted the two distances, right? Right, and then it will equate it to the total mile that they're gonna. So we're gonna shift gear to a different type of problems. The problems now are about payroll, work hours. Okay, see the first one there. It says that Elena works for $8 an hour. A total of 25% of her salary is deducted for taxes and insurance. How many hours must she work to take home $450? I mean, almost all of us understand what this kind of problem. When you work, they deduct from your pay different kinds of things. The first thing is taxes. The second thing, if you have insurance through your job, they deduct for that too. If you are in the union, they deduct for that too. So there is a lot of deduction going on. So, but this one said 25% is a total of 35% of our salary is deducted for taxes and insurance. How many hours must she work to take home $450? So notice what is going on here. We're looking for hours, man. We're looking for the number of hours. Again, this boils down to linear equation in one variable. Okay, we'll say let x be the number of hours. Okay, the number of hours she worked. Okay, worked. Okay, and then the rate is $8, deduction 25%. So that means before deduction, right? That means before any deduction. Okay, any deduction, she would earn 8, because she makes $8 an hour. She would take that. She would take that home, right? But then when they do the deduction, see, they're looking for take home. Well, they give you take home of that. Take home, take home, okay? Take home will be 8x minus deductions, right? 8x minus deductions, okay? But what are the deductions though? Deductions will be whatever she makes. You have to subtract whatever she makes is 8x, and then you multiply that by the deduction right here by 25%. Remember, we'll talk about this in arithmetic. 25% just means 0.25, okay? So this is what we're looking for. So the take home will be that's that. It will be 450. Okay, so we want to solve. If we get x, if we solve for x, then we'll get basically x stands for the hour she must work. Okay, to get this deduction, and we'll form this equation. Make sure you understand it. This is what she will make. You take what she will make, you multiply it by this. Take what she will make, multiply it by 25% deduction. Then you subtract that from what she will make. That's all. Okay? So this is very, very intuitive. If you just think about it clearly, that's how they calculate your pay. If you're making $70 an hour, you replace 8 by 70. You're making $200 an hour, you replace 8 by 200. That's all. So we'll try to solve this thing here. We'll get rid of the bracket on the left. We'll get, let me see, 8x times 0.25. What is that? That's what you gotta multiply that out. That way you can see. Another way we could have written that. We could have written the whole thing. If we don't want to work with fraction, we could have converted the fraction like this: 8x times, because that fraction stands for 25 over 100. You remember we did that. So if you divide that fraction, we could have written it like this: 450. We could have written it like this: x minus 8 times 1 over 4. Okay? That is 450, okay? And then we could have said that, let me see. It's the same thing as 8x minus 8x over 4. You see that, right? It's equal to 450. I'm just playing around with the numbers based on what I know. Do you understand? We can do that one like, make sure this one has a denominator of 4. That way we can combine. How do we do that? Okay, so here is how we do that. This is it. Oh, sorry, man. What is wrong with it? This is 8x, and this is 8x, okay? 8x minus 4, okay? How do we play that trick? Basically, we'll multiply 4 times 8x divided by 4. That's 8x over 4 is equals to 450. Did you get that? So when we combine the left side, we'll get that. We'll get 4 times 8x minus 8x, okay? Is equals to 450. See that? So we need to simplify the left side. I'm sorry, that's 4 times 8x. What does that give you? 4 times 8x will give you 32x minus 8x is equals to 450, okay? Alright. So 32 minus 8, you see, that's what you get, 24. 24x over 4 is equals to 450. Okay, you see what I'm doing, right? See how clean it is? You divide 24 by 4, what do you get? You should get 6. 6x is equals to 450. Okay, x is equals to 450 divided by 6. What do you get there? 450 divided by 6, and you get 75. You see that? So x is equals to 75. X is 75. So what do you do with that? What are the actions? Let S be the hours work. How many hours must she work to get? Okay, so she must work 75 hours, man. She must work 75 hours to get that. You see the problem? See how we solved it? She must work 75 hours to get $450. You see it, right? It's relatively not that difficult. It's just the algebra. The algebra was trying to simplify, made it like it's difficult. It's not difficult, man. You just have to keep working on it until you get the whole thing simplified, okay? But anyway, that's what is going on. You can do it any way you want. You can multiply 0.25 times 8x. If that's easier for you, but I did it my way. Do it any way you want. Okay, so we'll move on to the next problem, okay? The same thing, payroll. It's payroll problem. Say Paula received a paycheck for $585 for her weekly wages, less than 30% deduction. How much was she paid before deduction were made? Okay, read that carefully. She got a check of $585, right? And that check, that $585, they deducted whatever she made. They deducted the 10% already before she get that. That's all that thing is saying. They say how much was she paid before the deduction. So the way they worded the problem here, the way it's worded from here to here is confusing. So in other words, that section there is saying she made the $585 after the deduction. I don't know, sometimes they try to make this a little confusing with their language. So, but anyway, that's what that is saying. If you need to price, because see, that's what so how much was she paid before the deductions, you see? Instead of them saying it, the simplest way, they want to, say convoluted way. That's what is going on there. Remember what we did before? We said the take home, basically take home is what you make minus deduction. You remember that? Let me write it a little bit here. Okay, you can say let X be what she should, what I call that gross pay. That's before deduction. Be gross pay. Be her gross pay. Okay. Gross pay is before deduction. Okay, keep that in mind. Gross pay. That's what the gross she makes before deduction. Okay, so we say that deduction basically. Let's say she makes that. This is the gross pay. Then they have to do deduction. And what is her deduction? 10%. Deduction means you take X, you multiply it by 10%. 10% is 0.10. Okay. Remember, you can say 0 over 100. That's 10%. Okay, I'll do it this way now. If you do this way, then it says all that thing is 585. So if you multiply this out, I don't want to go. I can do it the way I did the other one too. Because you see, look at this. X minus X times 10% is basically 10 over 100. You understand that, right? All that thing is 585. You understand that? I mean, that's how I like to solve it. You can multiply, say, 0.85 you can say 0. I don't know what that means. 0.10x. But I don't want to work with percent like that. I mean, I don't want to work with decimals like that. I like it this way. That way I can see what I'm doing. Okay, so that was the same thing as x minus 10x over 100. You see that? All that is equals to 585. Okay, so we'll play tricks. We want to get these, we don't want to have a denominator here that is 100 too. That way we can simplify stuff. So we'll say 100 times 100, which is 1. X minus 10x over 100 is equals to 585. See that, right? Okay, so basically we'll have 100, we'll have the same denominator now. We'll have 100x minus 10x. Okay, it's equals to 585. You see that, right? Just look at it carefully. Then if you go ahead and simplify the left side, you have 100x minus 90 minus 10x is 90x over 100. Okay, it's equals to 585. All right, see that, right? Okay, so you can cross multiply now. You have 90, because this is over 1. It changes nothing if you put 1 there. It's 90x times 1 is equals to 585 times 100. Okay, when you multiply anything by 100, it just adds 2 zeros. So it's 90x is equals to 58500. X is equals to 58500 over 90. You see that, right? You cross out the extra zeros, and then you say, then you do 580 divided by 9, okay? And then you get 650. You see that, right? So x is equals to 650. That's what she made before deductions. You see, x is gross pay. That's before gross pay is before deduction. So basically we are done with this problem, man. She made that before gross pay, okay, before deductions. Okay, so we'll move on. We're done with that one. We'll move on to the next one. Okay, so just moving on. The next one is, it says, I'm having problem with this thing here. You can make it larger, smaller. The next one says, at the end of a day, the owner of a gift shop had 2,394 in the cash register. This amount includes sales tax of 5% on all sales. Find the amount of the sales. Okay, it's the same idea, man. All right, it's the same idea. If you have a shop, your company is registered with the government. You have to collect tax for the government, and then whatever tax rate they have, if somebody buys something 1,000, you multiply that by tax rate, get what you're supposed to tax them, and then you add it to that 1,000. Okay, so basically the tax rate here is, the sales tax rate here is 5%. So in a short summary, you take 5%, you multiply 2,394, you get an amount. Okay, and then you subtract that amount from this whatever you get, subtract it from here, and then you get the amount of the sales, right? Without the amount of the sales is without the sales tax. Okay, so but let's do it. We say let x be the sales. Okay, amount of the sales. Let x be sales, right? That sales without taxes. Okay, all right. Okay, so what you can say, remember that that's without taxes, but then you get taxes. You're gonna get taxes. You're gonna get taxes on that. You remember, like I told you here. So you say X. It's a similar thing we did with pay, with the gross pay. Gross pay we did earlier before this one. See, the same idea. So this the sales amount right there, F plus. Actually, is it plus? No. Yeah, it's plus sales taxes. You gotta collect taxes. So 0. What is 5%? 5% is 5/100. You multiply it with X. Multiply X. That's what you're gonna collect in taxes, and then you equate it to the amount. So I hope you understand what we're doing. You buy something, they have to take taxes. The tax is based on the amount, the price of the product you're buying. So they would take the percentage, they multiply it with the amount of the stuff you buy. The amount, the price of the stuff you're buying is right there. They take 5%, they multiply with the price, right? By doing that, they collect. That's the tax they will collect from you. Then they're gonna add it to the price, the original price of the product. So when you add all that together, it's equals to what you pay. Do you understand? Because this thing here includes the taxes. Okay. So this is a simple linear equation in one variable. Okay. All right. So how do we proceed? We play the tricks. X on the left, we multiply it by 100. We multiply. I mean, we could try to simplify. We can do it this way, or we can simplify this 5. Let's do it this way. That's fine. You can do it any way you want. 5x/100 is equals to 2394. Okay. Okay. So you do it any way you want. You can cross 5 and 100, but I don't want to do it that way. We can do it that way too, but let's continue the way we're doing it. Then we'll combine those two. We'll say 100 x plus 5x, you get 105x. Okay, it's equals to 2394. Okay, we can put 1 up below it. All right, you see that, right? Then we'll cross multiply. If you cross multiply that, then you get 105x times 1 is equals to 2394 times 100. Whenever you multiply with 100, all it does is add 2 zeros. So 105x is equals to 239400. That's all. Okay, so you say x is equals to 239400 divided by 105. That's all. That's all we're looking for. Because x is the cells without. Cells without. What did I do here? X is the cell without taxes. Okay. All right. All right, so all right, so sorry about that. Okay, so you do that. What do you get? If you see me making a silly mistake like that, just understand it's a silly mistake. Okay, so we divide that by 105. I don't know what it will. Yeah, it comes out a whole number. It's a 2280. So x is that. That's the cell without the tax. You see, they added about $14 in taxes, because this is the price of the product. Find the amount of the cell. Basically, when they say find the amount of the cell, is the price of the product, and then they have to add tax to it. That's all. Okay. So you see what we did, right? This is actually in dollars, so we're not worried about that. Okay, so we'll move on to the next one. See that linear equations in one variable, it can be very useful. It's all over the place. You can use it to design all kinds of questions. I'm talking about real world questions, real world application questions. So, but anyway, let's read this one. A restaurant bill totaled $180, which included a 20% tip. Find the actual price of the food and drinks served. Okay. So they say 180 they collected included 20% tip. It said find the actual price without the tip. So basically, in a nutshell, 20% of 180, you find that, and then you subtract that from 180. That's what that problem is saying, man. You gotta think through it. They collected 20%, so you multiply that thing, and then that's basically in a nutshell. But let's solve it the right way. We'll solve it the right way. We'll say let x be, find the actual price. Let x be the price, okay? This is the price without the tip. Without tip. Okay? Alright? And then don't forget now. So if you have price plus tip, that's x plus tip. Alright? Will be equal the total the person paid, okay? Okay, but we say 20% is tip, and that's the actual price. So basically, you see the same thing we did before. So you say x plus 20%. Remember, I told you, multiply by 20% is 20 over 100. Multiply, with x, then you add it to the actual price, then you get the total, which is 180. See, you see it, right? All right. So that's what they're saying. So I'm gonna solve it the way. I mean, if some people like to solve it by multiplying 20% with x. They get 0.20x. I don't like it that way. I try not to work with fractions, so you don't have to. So let's do the trick here. See, if let me tell you, if we can do it another way. 20 go into 100. What do you get? 20 divide 100. I think you get 5, right? If you take 100, you divide by 20. What do you get? You get 5. So let me rewrite the problem. If you want, we can rewrite it. Like, you don't want to work with 100. 100 is too large for you. Then you can say x over 5 so equals to 180. You come up with the same answer. And then you do our trick. You say x on the left side is 5 over 5 like that, because 5 over 5 you cross it out is 1, plus x over 5 is equals to 180. You see that, right? And then it becomes this is the same thing as 5x over 5. You see that, right? You see? Now they have the same denominator, and then you say 5, you add them, that's 6x equals to 180, okay? So you can cross multiply. You can cross multiply, and then you get 6x is equals to 180 times 5, okay? What is 180 times 5? The thing is, you try not to make the problem too hard, 900, okay? 6x equals to 900, then x equals to 900 over 6. What is that? 900 divided by 6 is 150. Okay, 150. See? the thing was 180. So basically they collected about $30 in tips. That's all that he's saying. He said they collected $30 in tips. So X is equals to 150. That's $150. That's the original price without the tip. The tip you give the whoever served you, a lady or a man, you see. So let's do this one. We'll move on to the next one. That one was done. So you gotta think this problem through. If you're collecting taxes or you're collecting tips, it's the same thing. You take the price of that thing, you multiply it by percentage of the tax or percentage of the tip. Okay? And then you add it to the original thing, original X, and then you equate it to the total. Basically, that's it. You gotta think that through. So here is another problem. It says Carter received a credit card bill for 104. This included interest of 1.5% per month for 1 month plus $5 late charge. To the nearest cent, how much were his actual purchase, the original purchase? So that's what he received. That's what he received right there. That then includes what that problem is saying. See, he received that bill. He received this bill here. I'm trying to make this behave well. He received this bill here, and that bill includes 5% fee plus late charge. So what did he buy? The actual price of whatever he bought. Okay, so think about it clearly. Okay, so if X is the actual price, then you gotta add them. You take X multiplied by 1.5%, right? And then you add whatever you get there, you add it to X plus you add that the $5. Okay, that's all that is saying, man. It's not that difficult. You just have to think it through. If you think it through, it will come out right. So don't be scared, man. So let's go. Then we're gonna say what we're gonna do. We're gonna say the way we're gonna proceed. We're gonna say let X be let X be the price of whatever he bought. Be price of whatever he bought, the product. Okay, price of the product, whatever he bought or whatever service he bought. Product or service, okay, it doesn't matter, product or service. He could have, could have been a service. I'm sorry, let X be that. Okay, let X be that. Let X be the price, okay? And then this is the same thing we did before. And then you have X plus he's gonna have to pay that fee plus 1 point. I cannot write this way. It doesn't hurt. So 1 times X. Okay, plus the late fee, which is $5. All that equals to 104. So try to understand the problem now, and then you won't have any issue. See, the way I like to deal with that, it says 1.5. That's 1.5 over 100. Okay, when I'm dealing with percent, it's over 100. Okay, so I'm gonna write that the way I like to write it. I'm gonna write about, it's gonna be a little it's gonna be a little confusing. 1.5 over 100. Okay, I'm gonna write it like that, but I'm gonna have to get rid of that fraction. So it's gonna be X plus 1.5 over 100 X times X plus 5 is equals to 104. You see that, right? Because anything percent, if it's 2.5%, it's 2.5 over 100. Okay? You can see that, right? See, that's why I like to deal with leave it, over 100. That way, there's no confusion. You see. So what we can do? Let's do it this way: x plus 1.5x over 100. Okay, is equals to 104 minus 5. We'll move 5 the other side. What would that be? That would be 99. Okay. So that would be 99. Look at it carefully. That's 99 if you move it the other side, okay? Alright. So now we'll have x plus 1.5x over 100 equals to 99. That's what we're dealing with. So let's simplify the left side. I'm gonna introduce our trick. It's 100 over 100 x plus 1.5x over 100. Okay, we'll have the same denominator, 99. You see that, right? So we'll have the same denominator. We'll have 100. All right. If you have 100 there, then you add those two. You will be 100. 100 and 1.5. You see that? X is equals to 99. Okay, so you multiply both sides. Okay, I mean you cross multiply. If you put 1 here, if you cross multiply, you have 101.5 x is equals to 99 times 100. Okay, that would be the same thing as 99. You just add 2 zeros. Okay. Okay. All right. So I don't like to work with decimals, so that we can do something about that, but it's okay. Suppose they don't have you to use calculator, that would be a little bit more involved. Do you know that thing you're looking at there on the left? Just bear with me. I will show you another way you can handle that. That's the same thing as 101. Same thing as 101, and then 5 over, what is that, over 10. See? You see that, right? And that's x is equals to 9900. You see that, right? That's what that is saying there. And then what you can do, 10 multiply 101, you get 1110. You add 5 to it, is 1115. So basically this is 1000, I'm sorry, not 100. If you if you multiply by 10, it's 1000. Hang on a minute, I don't want to confuse you, man. Yeah, what happened, I'm trying to avoid working with Trapezoid. If you multiply that out, you have 1, and then you have 10 here. Just add 1 0 and then plus 5. Okay, over all that is over 10 equals to 9900, right? I guess some people, if you work with decimal, it might be easier, but I don't know. I think this is a straightforward way, even though it's a lot of writing. It's okay though. So that's 1015 over 10 is equals to 990. Because you see, if you divide that, if you divide 1005, you divide it by 1015, divide that by 10, you get the same thing we had over here. You get that 101.5. Okay, so this is, don't forget the x. So you can cross multiply again. You have 1015x is equals to, if you put 1 there, it's equal to what? 9900. You add 1 more 0, and then you say x is equals to 99000 over 1015. If you do that, what do you get? You see that, right? I know it's a lot of writing, but if you keep doing it slowly, pay attention to what you're doing. I know when you do a lot of writing, you may make a mistake somewhere. Basically that comes out, it comes out to x is equals to 97, right? Point. We're working with how many decimal places? One decimal place. What does the problem say? The problem doesn't specify, so I'm gonna put it in one decimal place, right? That would be 97.5. That's what that would be, and that's in dollars, man. Right? Yeah, that's in. Okay, that's what he. That's the amount he paid before they add this, before they add that and added that. That's what he paid for the product. See? So basically we're done. It's a little messy, but that's how I like to do it. If you do it the other way with the decimal point, you still have to divide, but anyway, so don't worry about that. Let's move on to something else. This is another problem here. What does he say? He says, Ricardo. Let me make it a little larger. Ricardo paid for something. I make it a little larger, that way everybody can see it in the video. He says Ricardo paid for something. Ricardo paid $7,000 for a used car. This includes 10% sales tax, less trading allowance of that, $1,250 for his old car. Find the actual price. Okay, it's the same idea, man. Basically, this is something you should understand. What that's saying is he paid $700 for a used car, and that price includes 10% sales taxes, right? And that also includes they deducted $1,250 for his old car. After they do all that, add taxes, deduct that, he paid $7,000. They want to find the actual price of the car. What is the actual price of the car? That's all they're looking for, man. So we're gonna do the same thing we've been doing. Just think through it carefully, because I know you've been in this situation where you had to buy a car or buy something. The price is let's say pick a number, the price, and you traded in. They have to subtract that before they actually. I think they subtract that before they actually do the tax thing. Okay. But so let's see how we'll go about dealing with this. Okay, we'll select this. Let X be the price. This is the price of the car, okay? Okay, that's the price of the car. Let's assume X is the price of the car. So you walk in there, they tell you X is the price, okay? But then you gotta do trading. You gotta trade in. Because you see what happened, they have to add taxes and then subtract what you traded in. Okay? Because you remember when you paying for the price of the product plus taxes. Right? So they're gonna take the price of the product like that, and then they're gonna add the taxes on it. What they call sales tax. Sometimes you have city tax, state tax. They add taxes to it. Sometimes you even have county tax. Some county has tax, and then they're gonna subtract what you get. The value of your old car. Okay. Value of old car. Okay. All right, that's what is going on there, and the value of OCA is there. Taxes is that. So basically, this is the same thing we'll be doing before. X plus 10% of X minus 1250. By the way, this is equals to what he paid, right? This is equals to the total paid, okay? So this is equals to 7,000. You understand? Because after all that, he paid 7,000. So once you understand the problem, it breaks down like that, you can see there is nothing to be scared of. What is 10%? So it's X plus 10% is 10 over 100, okay? Minus 1250 is equals to 700. So basically what we do now, simplifying it. You can simplify any way you want. I like to simplify it this way. So you can say X plus 10x over 100 is equals to 7,000. You move this to the other side, it becomes positive 1250. Okay, so let's simplify both sides. We're gonna put our trick. See 100. Well, before we do that, let's reduce the numbers. Let me reduce the number. That way we're not working with huge number. Let's reduce the number first. This was something as X plus, if you divide that, okay, it will be X over, so you're taking out 10, it will be 10, okay? You see that, right? So what is that thing on the right hand side? Is 1,250. You're adding it to 70,000, okay? So what is that? If you add it to 70,000, because you don't want to make a mistake anywhere. If you make a mistake, you come up with the wrong information. If you add that, because it's 1,200, it will be 8,000 plus 250, okay? And then what do you do here? Now let's use our trick. Our usual trick will say 10 over 10, which is 1, and then X plus X over 10, okay, is equals to 8250. You see that, right? So we'll combine, because they have the same denominator now. You combine, you have 10x plus x, okay, is equals to 8250. See that, right? And then you have 11x over 10 is equals to 8250. Let's say over 1. If you cross multiply, you have 11x is equals to 8250 times 10. You add one more 0, that's all. And then x is equals to 82500 over 11. That's all. That's all what we're gonna end up with. You add one more 0 there, and then you. I hope you see what. If you don't understand what I did, because anytime you multiply with 10, multiplying with 10 means add one more 0. That's all. Multiplying with 100 means add 2 zeros. Okay, so that's what I just did there. There's no need to be writing all that stuff. Okay, so x, if we divide that, x will be 7,500. That's what that means. That's what he paid. Let me see. That's what he paid. That's the actual price of the car he purchased. 7,500. So that's extra 500. After they deduct that thing, 1,250, and they added taxes. So the actual price of the car is there. Anyway, so that's how you do it. It's a bunch of writing, so you just keep writing until you get the whole thing done. Let's do the next one. I'm gonna make it as large as possible. That way people can read it in the video. Because when they play the video, they should be able to read it. All right. Okay, so Kevin is 3 times as old as Bob. Now the problem has changed. You switch to something else. Kevin is 3 times as old as Bob. 3 years ago, the sum of their ages was the sum was 22 years, right? The sum of their ages, okay, 22. So they're kids. How old is each now? Hint: write an expression first for the age of each now, and then for the age of each 3 years ago. You see what that problem is saying? So you gotta read them. You gotta get through the words, man. I keep saying that. You gotta get through the words. They put a bunch of words, man. And then remember what we did when we saw something like this. You gotta take your cue from here. Kevin is 3 times as old as Bob. That's given. And then he said 3 years ago, the sum of their age was okay. So 3 years ago. I think this is the current, see, he said is, not was. He said is, was right here. They're looking for their age now. Okay? Okay. So the current, we're looking for the current age. So because you gotta take cue from Bob. Say Kevin is 3 times as old as Bob. So let X be okay. Bob's age today, okay? Today. This is his age today. Alright? Because they say Kevin is 3 times as old. So that means, so if you suppose this, then if you suppose this statement we made here, right? This statement, if you suppose that, then it means that Kevin, because Kevin is 3 times, it means that Kevin is 3x currently. That's Kevin's age. 3s is Kevin's age today. That's what that means, because that's what it says here. Okay, 3x is Kevin's age today, okay? And then in that sense, say 3 years ago, the sum of their ages were that. How old is that? I don't know why they brought 3 years ago. Okay, it's okay. 3 years ago, okay? 3 years ago. 3 years ago, what was Bob's age? Bob's age will be x minus 3. 3 years ago, you see that? Yeah, 3 years ago, Bob will have been. You gotta subtract that from Bob's age. The same thing with Kevin. Kevin will have. Well, let me write this a little better. That way, when you reason it, it makes sense. Let's write it a little cleaner. 3 years ago, okay? 3 years ago. Okay? Bob's age that time was, what is that? X minus 3. Because 3 years ago, Bob's age, Kevin's age 3 years ago is 3x. Remember? Minus 3, because they gave us that condition. Okay? Alright, and they said 3 years ago the sum of their age was 22. You see that, right? It's just a chain of conditions, that's all. So 3 years ago the sum of their age, so you sum it. I'm sorry. You sum their age 3 years ago. Minus 3 plus 3x minus 3 is equals to, that 3 years ago it was 22. That's the sum of their age, right? You see what is going on, right? So if that's the case, you create that, then that would allow you to find, because X is the current age, that would allow you to find what is going on today, how old they are today. Okay. You got that. That's the equation with one variable linear equation. So we'll simplify the left side. You get X minus 3, remove the brackets, 3x minus 3 is equals to 22. Combine stuff and move things around. X plus 3x. What is this? Did I make any mistake? No, it's okay. Minus 6 is equals to 22. So you combine and move things, you get, what is it, 4x. Move that over, move 6 over to the other side, it changes sign. It's equals to 22 plus 6, which is 28, okay? Alright, so x, all for x, divide by 4. X is equals to 28 divided by 4. What is that? You see what I'm doing, right? You know, once you set up the equation, the rest of the stuff are easy, man. Once you set up that's 7. So what does 7 mean? You gotta go back. Let X be Bob's age today. So today Bob is 7 years old. Bob is 7 because X represents Bob's current age. And then Kevin is then, see what it says? Kevin is 3x. Kevin is 3x today. Okay? So that, what is that? 3x is 3 times 7. And that's 21. So today Kevin is 21, Bob is 7. I think that's what they want. You see? That's what they want. You know, so we're done. We're done with that one, man. There's nothing else to do. We'll finish with that one, so we'll move on. The next one, the example 19. You know, I'm gonna end this video soon. I do this one, do one more, and we'll end it because it's gonna get too large or too long. So let's make this a little bigger, that way when the video is playing, people can see it. Make it as large as possible. Let's see that. All right. So you see what that is saying? That says a store has 39 quarts of milk, some in pint cartons, some in quart cartons. There are 6 times as many quart cartons as pint cartons. How many quart cartons are there? Hint, 1 quart is equals to 2 pints. So they got 1 quart equal to 2 pints. Alright, so again, you try to understand what they're saying there, and then you see what is going on. He says the store has 3 quarts of milk, some in pint cartons, some in quart cartons. There are 6 times as many quart cartons as pint cartons. See, that's your cue right there. See, that's, you take a cue from there. There are 6 times as many quart cartons as pints. So pint should be our starting point. Okay? And then how many quart cartons are there? How many quart? Okay. So we say let X be number of pint carton, okay? Again, we took our cue from there. There are 6 times as many quart cartons as pint. So if you represent pint with something, then quart will be 6 times. You see that, right? So that's where the logic starts. You gotta pay attention when they're doing comparison like that. Okay, so if that's the case, then we'll say there are 6x quart cartons, okay? Quart cartons. You see that, right? That's what that is saying. And then, you see, they gave you that condition, 1 quart equals to 1 pint. But so I think it's the best thing to, okay. See, that is in quart. That is in quart, and that is in pint. So what is that condition? They say one quart is equals to 2 pint. That's the condition they gave us. Notice something. If 1 quart equals to 2 pint, then notice you can divide it. I wanna get what is does 1 pint represent. Then 1 pint, based on that equation they gave us, 1 pint is the same thing as 1/2 quart. You see that, right? See, that's why it's good to know how to do all this, man. Because you multiply from here, right here, you multiply both sides. I mean, you divide both sides by 2. You get 1 pint equals to half quart. Okay. So this is 6 quart we got 6 quart here, and that's we got 6 quart cartons, we got X pint cartons, okay? So basically what that means is 6 1 pint is done. That means that to find the total, remember, you're gonna find the total. Hang on a minute. So you're gonna find the total like this. What did they say? There are 6 times as many quarters. How many quarters are there? They say the store has 39 quart of milk. Okay. So the total they have. So if you say this is X, this is in pint or in pint, because that's what we said here. We said that here. So basically it says X plus 6X 39 will be 39, right? Because you see, we say let X there, and then we say let 6S there. There are 6 times as many quart cartons as pint. Okay. So what we're gonna do, we need to replace it with that. So we say instead of 1x, you will have, because this here is 1x, okay? Instead of that, we're gonna have half x, because 1 pint is equals to half quart. So you see that, right? I don't want to confuse you, but that's what is going on there. It's gonna be half x plus 6x equals to 39. That's the basic equation there. You just have to try to read it carefully, reason it out. That's what you have there. That's what we need to solve. Then we can play our trick, because we're gonna combine the left side. We'll have x divided by 2. So to put this in the same denominator, that way we can easily combine. We'll say, let's see. Basically, we're saying 6x 2/2, okay? That's what we're saying there. 39. Okay? 2/2 is 1. Alright, so that gives you x/2 plus 12x/2 is equals to 39. Okay? So we'll combine the left side. We'll have 13x, because that's 1x there. 13x is over 2 is equals to 39. You see that, right? So you can say 39 over 1. You cross multiply, you get 13x is equals to 39 times 2. You see that, right? You have to just, follow the logic. Don't jump the gun. When you try to jump the gun, that's when you make mistakes. Okay? 39 times 2 is what? What is that? That's 78. Okay? And then 13x is equals to 78. And then x is equals to 78 over 13. What is that? You divide that by 13, you get 6. Okay, x is still represent point. So what that means is, because you initially remember we said here, let me show you, x, no matter what you say, x still represent point. Okay, so if this is point, that's all I'm saying. This is point. It's in point. Okay, I'm sorry, right here, I'm forgetting that part. Then there are 6 quart cartons. So what you do, so quart cartons are there, quart cartons right here. So then that means you multiply 6, right? 6 times 6. You see that, right? 6 times 6 is what? Forget about that. That's useless here now. 6 times 6 is 36 quart cartons. Okay, quart cartons. That's what we get there. You see that, right? Because I forgot what we did. It's too many conversion. So we got that, and then we got that. So once you get x, then you find what quart. This is pint. Once you get x, then you do like we normally do. So I'm sorry about that. That problem is a little confusing. Sorry about that. Let's move on to the last one. That way we can conclude this stuff. Let's see. Alright. So let's see this here. This says, he said a table is 3 times as long as it is wide. 3 times as long as it is wide. If it were 3 feet shorter and 3 feet wider, it would be square. With all sides equal. How long and how wide is the table? Let's make sure we understand it. Alright, let's read it again. Actually, this is a simple problem. You just have to understand what they're saying, man. Like I told you, the words will get you. You gotta get through the words. He says the table is 3 times as long as it is wide. Take your cue from there. So we'll do a step at a time. So we'll say we're gonna work with width because it's 3 times, the length is 3 times the width. So we'll say let x, it doesn't really matter what we use. We can use W for width. Okay, that way we'll know when we end, we'll know what we got. Let's see, this W be the width. Okay, be width. Okay, the width of the table. Okay. Okay, so because we know we're dealing with one linear equation in one variable, right? We know that, so we don't want to make it complicated. So then he said the table is 3 times as long as the width. That means if that's the width, then the length will be you gotta cut off the word. Length will be 3w. You see that, right? You see that, right? So that's what that part says there. So let's go to this part. He said if it were 3 feet shorter and 3 feet wider. See, when they say shorter, they're talking about the length, and 3 feet wider, the width. So you say if it were 3 feet shorter and 3 feet wider, it will be square. It will be a square with all sides equal. You see that is important. it will be a square with all sides equal. Understand that? So if it will be 3, if the length is 3 feet shorter and the width is 3 feet wider. That's what it's saying, man. Okay. So let's, like I said, the word will get you, man. So the second condition is, let's see, what is if the length. The second condition has to do with the length and then the width again. So this condition here is if it's the length is 3 feet shorter. That's you take the width 3W. Shorter means subtract 3. Okay, because 3W is the length. And then what is the width? The width, they're talking about width will be 3 feet wider. So in that case, it will be, where is the width? The width is right here. So it will be W plus 3. You get that, right? So, yeah, English language is sometimes it's good language, but you gotta pay attention to what they're saying, man. You have to try to understand what they're saying. So then the width will be 3 will be added to the width, and in that, given that condition right here, I don't know what that's language, man. They should have said if the length were 3 feet shorter and the width 3 feet longer, so wide or whatever. See, when they say shorter here, they didn't mention anything about the length. Anyway, that's what they want. So we'll go. I don't want to see here engage in semantic analysis. So, but that's what, just cut up the words and get the equations, and then you're good to go. And then what do you say again? If this condition hold, then he said it will be square with all sides equal. You see, you gotta put that into consideration. Then you say how long and how wide is the table. So if that's the case, the sides will be equal, which means it's a square. So what they're saying there is 3W for the length. 3W minus 3 will be equals to W plus 3. So sometimes every word counts, when they're describing this stuff. That's all they're saying there. Then you have to see how long and how wide will it be, will the table be. Alright, so everything this is equation, linear equation in one variable. So you have to just try to move things around, put the variable on the left, put the constant on the right. So you got 3W minus W is we'll bring W. I just brought W from the right to the left and change the sign. We'll do the same thing. We'll take this to the right and change the sign. We already have 3 here, and we'll bring another 3, change the sign right there. See? So what happens there? This is 1W. So that will be 2W, because it's subtracting 1. It's equals to 6. So W, you divide by 2. W is equals to 6 over 2, right? You see that, right? That's 3. So W is equals to 3. See, that's all they're saying. So then how long and how wide? So the width will be that, and then the length. This is the width, because that's what we defined it to be right there. Originally the width is that. That's the width, right? Then the length is that. Okay. Hang on a minute. Yeah. So yeah, we use what we, because you see, we use this condition to solve get W. So we'll go back to the other condition, the original condition. Okay. So then the length will be what is that? 3W. It will be 3W, which is the same thing as 3 times 3 is 9. Okay. So the length will be 9. Is that? Yeah. the length will be 9 feet. All these are feet. This is feet, this is feet. So, and I think I'm done with this thing, man. Let's leave this series. Please subscribe to my channel, like and share this video. If you have any question, leave it under the video. I will answer them. Alright, thanks for coming. I'll see you in the next video. We're gonna continue. I think this is the end of the I'm gonna stop here for linear equation in one variable. Next time we'll move to linear equations in 2 variables. Okay, thanks for coming.